Hi, pals. Today we are going to be looking at the solutions for some of the questions we were given in the previous lessons exposition. So we are given a couple of questions as take home in the previous exposition, and so today we're going to be looking at a solution. So if you have not gone through the previous exposition, I advise you to do that right away before we dive into this. So quickly, now we were asked to get the radical for this very ion in the previous exposition. This was one of the questions, the very first question we were given. So this is PO4. So here we have one atom of phosphorus and 4 atoms of oxygen. So the first thing we're going to do is we're going to write that down. We're going to be getting the atomic number for each of them. It was said that oxidation numbers are used to get radicals. So phosphorus first. So phosphorus has atomic number. Phosphorus has atomic number of 15. So what is going to be the electronic configuration? That is going to be 2, 8, and 5. Now don't forget that according to the electronic configuration for the first 20 elements, we use a 2, 8, 8 shell filling. It means the first shell takes 2 electrons, the second takes 8 electrons, the third takes 8 electrons also. So for phosphorus, we have the first shell taking 2, second taking 8, the third 5. That makes it 15 altogether. So phosphorus is not complete. It means the oxidation number for phosphorus, it means phosphorus has to either borrow 3 electrons or give out these 5 electrons in the top shell to attain a balance. So it means phosphorus is either plus 5 or minus 3. So that was said already in the previous exposition. So the next is oxygen. Atomic number, oxygen has atomic number of 8. So the configuration is 2 for the first shell, 6 for the second shell. So the second shell is not complete. It needs 2 to become balanced. So it's either going to give out the 6 or takes in 2. So it's plus 6 or minus 2 for oxygen. So what do we do next? It was said that the very first one, you're advised to use the positive oxidation number for the first, while the second you're advised to use a negative oxidation number. So how many atoms of phosphorus do we have here? We have just one atom of phosphorus. So that's going to be 1 times, what's the oxidation number for phosphorus here? That's plus 5. We're going to use plus 5 there. Then plus oxygen. Since we've used the positive one here, we're going to use negative one here. This minus 2. So that'll be 4 times minus 2. So plus 1 times 5 is plus 5. 4 times minus 2 is minus 8. So that'll be plus 5. Plus is minus. Plus 5 minus 8 will give us minus 3. It means PO4 is, that is tetraoxo phosphate 5. It means PO4 is an anion. It's a negative radical. So that's what it is. Now, here's the next question. We are given this question as the second question in our previous expositions take home. So this MnO4, this tetraoxo 7. This MnO4, so it's magnesium, 1 atom of magnesium and 4 atoms of oxygen. So what's a radical for MnO4? What's a radical for this? Now don't forget, first of all, we're going to get the oxidation number. So for magnesium has this oxidation number as plus 7 to be precise. That's the oxidation number for magnesium. The oxygen has this oxidation number. Oxygen has plus 6 or minus 2. That's the oxidation number for oxygen. So how do we go about this? How do we do this? So this manganese, I beg your pardon, not magnesium. This manganese has 1 atom. So that's going to be 1 times plus 7 right here, plus oxygen has 4 atoms. So that is going to be 4 times minus 2. So 1 times plus 7, that's plus 7, plus then 4 times minus 2, that'll give us minus 8. So that's going to be plus 7. Plus is minus. Plus 7 minus 8. Together we end up having minus 1. So 1 atom of manganese, 4 atoms of oxygen, which is tetraoxo 7. It means MnO4 is a negatively charged ion. So this is an anion also. Just a minus. A 1 minus. Okay, it's high time we worked on the oxidation number. Now, this ones we're about to work on now, these ones belong to the second set of assignments or take home we're given. So right here, we have the radical given already. The radical, this is a neutral setup, this is a neutral stuff. So this neutral, it's not positively charged, it's not negatively charged. So we asked to get the oxidation number for OH, this hydroxyl ion. So how do we do that? Don't forget something. It's very, very important for you to go through the previous association if you didn't go through it or you've not gone through it. So we're told that for us to get the oxidation number, it's not going to be difficult because we're just going to do the same thing we did to get the radicals. But this time around, one of the oxidation number is not given, and the other one, the oxidation number is known already. So we just combine them together, we end up with what we have here. So as you can see, this copper here was the oxidation number for copper. We have just one atom of copper here. So oxidation number for copper is +2. That's a simple copper. So that's going to be 1 times +2. Then plus right here. Now, before we even carry on, let's do this. This is copper right here. Then this one atom of oxygen in this bracket. Then the two outside here, according to this law, whatever is out here, we end up affecting all what is right in the bracket. So oxygen here is just one atom. So 1 times 2, that becomes 2 atoms of oxygen. The hydrogen also is 1 atom. So 1 times 2 is 2 atoms of hydrogen. So that's just that. But there's no need for that because they are both together. So we just write that 2 hydroxyl ion like this. Let's find our way. We have to get the OH together. So by the time you combine all of them together, we end up getting 0 because there's no charge. This is neutral. So when we do that, the next thing we do is this. So let's carry on. 1 times this is +2, then +2 OH equal to 0. So we'll collect our like terms. We'll send this to the other side. So this 2 hydroxyl right here, this -2 over here also. So divide both sides by 2. So OH is -1. So the oxidation number for OH hydroxyl is -1. So if you got this, it means you really understood what we took in the previous association. Okay, still on the oxidation number. This is the next question. This is the fourth question, but the second one for the oxidation number that we were given as a take home. So here we have lead nitrate. We have lead nitrate right here. So you can see this an atom of lead, and right here we have 1 atom of nitrogen right in the bracket, 3 atoms of oxygen also in the bracket, and 2 atoms for general case for the 2 of them, that's for the nitrogen and oxygen. So the best thing we have to do first is you can state it out again. We can restate it out. Here we have our PB. That's a lead right there. So the nitrogen has 1 atom right in the bracket. So that's 1 atom of nitrogen in the bracket times the 2. That's the 2, the general 2 outside. That's going to be N2. So 3 atoms of oxygen right in the bracket times the 2 general atoms out there. That'll be O6. So the same thing we did up there, but for the copper hydroxyl or hydroxylamine, it's simply because of the fact that the O and the H, the oxygen and hydrogen, we are together. But this is a different case here. Nitrogen is right on its own and oxygen is right on its own. So it's better for us to get it done this way. Now the first question is, what is the radical? This is a neutral stuff. This is neutral. There's no charge on it. So it means by the time we're done combining all the oxidation numbers they have, we end up having 0 as a radical or as a charge they carry. So first of all, the lead has 2. So we have 1 atom of lead here. So that's going to be 1 times the lead, which is 2, plus 2. That's known already. Then the nitrogen, which is what we are looking for. We're looking for the nitrogen. So how many atoms of nitrogen? That's 2. That's 2 nitrogen. Then oxygen is 6. 6 times oxidation number for oxygen is -2. So we'll combine everything together. We end up having we end up having 0. So what do we do next? The next thing you have to do is just to finish this up mathematically. So 1 times +2 is +2. +2n. So 6 times -2 is -12 right here. Equal to 0. So +2 nitrogen plus or minus -12 is 0. So collect your like terms. 2 minus 12 plus 2 nitrogen equal to 0. 2 minus 12. 2 minus 12 is -10 plus 2 nitrogen equal to 0. So -10 crosses to the other side. It's 2 nitrogen equal to 10. Divide both sides by 2. So nitrogen is 5. That is the oxidation number for nitrogen. Okay, this was the last question we were given in the previous exposition. Now we are asked to get the oxidation number for phosphorus in this very compound HN3PO4. Now don't forget that that right here we have a neutral radical. That's what we have here. There's no charge here really. It's not positive, it's not negative. So the first thing we're going to do is to get the oxidation number for the ones we know. Hydrogen has an oxidation number of 1. Oxygen has oxidation number of -2. So let's see what phosphorus is going to have at the end of the day, because by the time we're done, we combine them all. So after we're done combining them, we end up having our radical, which is neutral, which is 0. So hydrogen, that's the first hydrogen, which is 3 atoms, 3 times 1, right here. Now the phosphorus, we just have 1 atom of phosphorus. So if you have 1 atom of phosphorus, it means it's going to be 1 times the phosphorus itself, the P, then the oxygen, which is -2, so 4 atoms, 4 times -2 all together, we end up having 0. So the next thing we do is to finish up. 3 times 1 is 3, 1 times P is P, the P we're looking for itself. The 4 times -2 is -8, equal to 0. So the next thing we do is to do this, we carry on. 3 plus P, plus is -8, equal to 0. So just collect your like terms. 3 minus 8 plus P equal to 0. 3 minus 8 is -5, plus the phosphorus itself that we're looking for. So send this to the other side. So phosphorus is +5. That's the oxidation number of phosphorus. So if you got all the questions right, it means you understood all we taught in the previous association. So at this very point in time, we're going to be drawing the curtain of today's association. So if you found this resourceful, please subscribe to the very channel and share this association. See you in the next association. Thanks.